I thought it'd be useful to go through some of the insulation products that are used in the bay window build, and also some of the related products for thermal efficiency. So first of all, I've got a bit of a label on each of the products showing the product name, the actual item, my cost, and the number of centimeters needed to achieve a target U value, which is the target 0.15, which is a target for a passive house retrofit. And all interior surfaces need to be less than 0.15. So that's excluding the windows. They can be higher, but generally all internal surfaces need to be below that level. And the reason is, it's thermal efficiency, but also if you've lived in a Victorian house, but the actual walls, although the internal temperature can be, say, 21 degrees, you can still feel the cold radiating from the walls, especially on the exposed external walls when it is cold outside. So the U value, ensuring the U value is below that level helps with comfort. The first product I used is what are called Thermo Blocks. So there's the item there, and we've got a 100mm thick layer of insulation, and wrapped within this insulation is a structural core. So if you look at that there, that gives the item the structural strength, the compression, I guess. And this can be used on foundations of walls, if that's the right word, but the bottom of a wall that you put your bricks or blocks on. And the aim of this is to insulate the blockwork above from cold rising from the ground. So there is 100mm there. And you can see how they manufacture it themselves in 2 layers of 50mm. So for this, I have a row of this below the blockwork, and that the main function there is to just keep the blockwork nice and warm. The brick base itself, the bay window base itself was made out of Thermo Blocks. So these are called, from a supplier called Whitehong. To achieve, for the thickness of the wall, when we had 215, to achieve target U value, you'd actually need, 73 centimeters of this to achieve the target U value for a wall. So in combination with these type of products, which aren't themselves very thermally efficient, you need to have specific insulation products, which I'll go on to later. But given the construction was going to be out of blocks, and given we could use these in the area, we decided to go for the blocks with the best thermal efficiency possible to make most of the construction. Say compared to brick, they're about 70% better than just a solid brick. So it's not as good as insulation itself, but it helps makes a difference. Now you can use these interior and external, and you can also use them below DPC. And looking at it, you'd probably think, well, just get wet, wouldn't they? Or attacked by frost, but no, they're totally suitable for that. But I was wanting to keep these as dry as possible because the thermal efficiency is better when it was dry. So that's where I decided to tank the construction completely with a tanking product. So this is the product here. It's a certain type of, I think it's called type 1 or something like that, so it's suitable for use below DPC, and its main use is to just ensure that these blocks and the construction are just as dry as possible. So this is the construction somewhat laid out. You've got the Thermo Blocks, then you've got the blocks, and then this is all encased in the tanking membrane. And then external to that we have XPS. Now that was used below DPC because it's somewhat resistant to moisture, and it's also resistant to just being attacked by garden spades and so forth. And there's 100 millimeters on there, so you're kind of seeing what we're trying to achieve is we want to keep this block work as isolated away from the cold as possible. So we've achieved that by not having a thermal bridge from the ground into the blocks, because this, and then exterior to that we then have this 100 millimeters of XPS that also helps protect the block. It's kind of the start of the build up, which is 215 and then 100 millimeters there. So we had the insulation, the block work. It was installed over bricks. So in this mock-up here, got the brickwork, kind of corbel foundations, and the 100 millimeters of XPS insulation, and a bit of a kind of a void here. So what we did externally is we had, and this is approximately 600 millimeters below the DPC, so it's quite an excavation there, and we decided we were going to backfill the area with foam glass, which is what we've got here. So the main reason for that is I wanted to try it out. We've got ideas about using this internally for kind of a solid floor, so I just wanted to partly see what the material was like. So the exterior was backfilled with foam glass, probably up to quite a width, half a metre. So the foam glass in itself gives good insulation for the below the floor to this area here. But in terms of the void here, we decided to pack the layer with foam glass and lots of lime putty to kind of hold it in place. So it was a bit of an experiment that I wanted to try. So below ground we do have quite a lot of insulation, and because it's below ground we can use products like XPS. For each centimetre, it's not as good as say PIR, which I've got over there. So you need more of the material to achieve the same U value, but it's not so much of a problem below ground. And then in addition to that we have this as well. So the U values below ground going into the wall here externally is it's pretty good. I think we've got below 0.1, so smashing the target that we're aiming for. As we move above the ground, above the DPC, then against the wall, the external wall insulation changes from XPS to PIR. Now this is it's a better material, so you need less to achieve a certain target U value, but it's slightly more expensive. So here we use 50 millimeters of PIR. Specifically for use as a external wall insulation to be rendered. So that's here. So the build-up reduces there from this 100, millimeters. It reduces down to 50. So that didn't quite, above ground, it didn't quite get us where we want to be with the U values. So I did then experiment a bit with using Aerogel. Now, it's probably not a recommended use, but if you imagine externally, the PIR is here, the 50 millimeters, sandwiched in the 10 millimeters of aerogel against this blockwork, tanked blockwork, and in between the PIR on the external side. So the reason for that was partly to get a better thermal efficiency of the wall above DPC, but also to try out that product, which is the aerogel here. So it's it's like a cloth. It's very dusty actually, and the process was to adhere it to the wall, to the tanked block work, using this adhesive here, which it kind of got the job done, but it didn't really want to stick to anything. Well, the aerogel, and it was a bit of a task getting it to stick to that, but it did work. So we have the build-up being block work, 100 millimeters of the aerogel, and then the 50 millimeters of PIR. Now, yeah, it's a bit of a weird detail. It will hold in place because above that we have the sill, and below it we've got this. So I'm not concerned about it flying away, but it's probably not something you'd do on a high rise. A bit of a backtrack on the build-up below ground. So here we have 100 millimeters of XPS. Now, I did actually have below ground, below site, 200. So I've got two of these. So I've got 200 millimeters of XPS. And then as we kind of move up the structure to above ground, it reduces down to 100. And then it's reducing down again to the PIR 50, which is external on the bay window wall itself. So the aerogel is the best insulation material. You'd need 130 millimeters to achieve the target U value, but the cost was quite a lot. I managed to get some aerogel as kind of the strip blanket, so it was a lot less cheaper than getting the wall board or stuff like that. Although the adhesive is something like £70 a tub, and I've used already 1.5 of those, so I haven't included that in the cost of the aerogel application. In addition to using the aerogel on the external wall insulation, I've used it between the sill and the bay base. Now, for the sills, because they're stool sills, the way you install them, you install them on, you apply cement basically on the area of the stools, but you leave the rest unsupported. So there's actually a centimetre gap there, which decided to fill that with aerogel. So that's what you can see there. And then we've got some additional aerogel mats here because the stool build-up is a bit higher on the sides. This is the old structure and this is the new structure, which was slightly higher. And there you can see the actual tanking which has been applied on the exterior sides. So yeah, the aerogel helps keep this wall again warm from the sills, which will be quite cold, and the idea is then to incorporate air tightness into this at a later stage. In another area we used Aerogel was in the sides here, just behind the jambs. There's a bit of a gap. So what would be a nice place to put some of the strips, you can see there, that's the Aerogel mat, and it's not hard or anything. This is the adhesive on it, so put the adhesive on the mat in, so then the finishing render will adhere to that. And it kind of insulates the wall a little bit. So here we have glass bubbles, and we've used this in the sills. So I made the sills myself, and I substituted half of the sand for these, partly because of weight, reducing the weight of the sills. It made the sills a lot more manageable to move around, but also it does have some thermal qualities as well, but it's very light. And it's used often, seems to be kind of a new product to compete with foam glass in terms of solid floors. Now, it's something I was just experimenting with. It worked quite well for the sills, but thinking ahead to the solid floor, we were intending to use this foam glass, and it's got good, it's below ground, so we've got the space to fill a solid floor with that much of product, and that will get us to our target U value. This is slightly better, which is good. The costs aren't equivalent. This is how much I ordered basically, because it went to the external, and this was 100 litres here, so 100 litres, and we had 2 metre square cube bags of that. But the thing with this is it's very, very dusty. I just didn't like using it. It's similar to the Aerogel, it's very dusty, which I didn't like using the Aerogel because of that. But this is, I don't know, cleaned. There's no dust at all really. Although you still use a mask, you just can't see the dust. So as an experiment to see what this is like, we'll probably use this for our solid floor rather than that. The other product we used was structural insulation. Now here we've got this compact foam, and it's used for windows basically. You can install windows into the material. This was another option, slightly less compressive strength or density is what that's showing. This I think was actually cheaper because you can get it as a flat product, and here I was bonding the two together to create something a bit like that. But in the end I went with something with a better density for the use I was doing. But I think this is a cheaper product. So I've covered the installation of these in separate videos, but this is the structural installation installed, fixed to the wall and adhered to both the exterior with adhesive, and that's forming the interior side of the bay window, and this is the layer where the window will be installed. And in a normal way, I understand, just with window screws into that structure. So that provides 100 of insulation, because the block work isn't very. It's a bit of a cold bridge, and that goes all around. This is the same material, so it insulates the wall. It's insulating the interior from the basically stone sills, you could say, concrete sills. Some of the products used, so I've used this is my preferred insulation foam because it's free of that product, and also used this airtightness paint. That was a bit of an experiment. I wanted to keep the area behind the jams dry, so it's kind of a bit like a damp-proof layer behind the jams, given where it is. And also it's airtight as well, and there were quite a lot of holes in the brickwork, so it certainly helps with that. The other product I spent a lot of time researching was actually these blocks, aircrete blocks. Now they're suitable for use below ground, well these ones are anyway, above ground, internal and external, and given the compressive strength in part A of building regulations, you can see where you can use these products. I was slightly concerned that they would get wet, and I only tanked them because to keep them as dry as possible for thermal efficiency. I'd say the tanking was probably a bit over the top, but a lot of what I'm doing here is experimenting. Some of the products are a bit over the top, like using this as basically an expensive MOT backfill. Gives a very good insulation below walls, but it's a bit over the top, and we only did that to try the product out. So out of the products, which one do I like the least, or don't I like the most? I'd probably say it has to be the Aerogel. It's just difficult to adhere to surface. You can get it, but the cost of the material is a bit over the top. It may be something I just have to use in certain areas because you can't achieve the U values without having lots of space taken up by insulation. Now, I don't know why, but this material is the white stuff is slightly worse than the better product of Aerogel about, but it seems to be in short supply, and that has a U value which is 10-20% better than that itself. So compared to using that and PIR, the main reason I would use this is because it's a Victorian property and we need some elements of the construction to be somewhat breathable, whereas using PIR, you're closing off the vapor. It's not able to move around the construction. So Aerogel is kind of the only option, I think. That's a bit more detail about the bay window build and some of the products that we've used and why we've used some of the products. I wouldn't recommend some of the products in the way we've used them because of cost. For example, using the foam glass as a expensive MOT type 1 is one experiment which kind of told us we didn't like the product, and then using the glass bubbles in the sills was useful for probably use that as a substitute for the foam glass when we get to actually doing the solid floor. I hope the review was useful. If you do have any questions or comments, then please leave them, and do remember to subscribe.